The James Webb Telescope saw something it can't explain. It was built to see farther than anything before it, to peer across time itself, to capture the first flickers of light after the birth of the universe. But what if, instead of confirming what we know, it's unraveling everything we thought was true? Since its launch, the James Webb Space Telescope has delivered stunning images of distant galaxies, glowing nebulae, and stars being born in the shadows of gas and dust. But hidden among its greatest triumphs are anomalies. Mysteries. Things it wasn't supposed to see. Today we're diving into those anomalies, the ones that stunned astronomers, and forced cosmologists to ask, did we get the Big Bang wrong? Chapter 1. The First Shock. Galaxies that shouldn't exist. It started with light, or rather, too much of it. Within months of its first full observations in mid-2022, JWST began finding ancient galaxies that seemed far too big, too bright, and too well-formed for their age. One galaxy, Sears 93316, was estimated to exist just 250 million years after the Big Bang. But it wasn't a chaotic clump of gas and stars. It was structured, mature, massive. And it wasn't alone. Dozens of other galaxies appeared far too early, impossibly early, given the current model of the universe. According to the Lambda cold dark matter model, it should have taken billions of years for galaxies to grow and stabilize. Yet here they were, mere hundreds of millions of years after the cosmic dawn, burning bright in JWST's infrared gaze. Some scientists hesitated. Maybe the redshifts were wrong. Maybe these galaxies weren't as old as they looked. But new data only deepened the mystery. So the question remains, how could galaxies form so early, unless something in our understanding is fundamentally broken? Chapter 2. The Impossible Stars. The surprises didn't stop with galaxies. JWST also detected what appear to be population 3 star candidates, hypothetical first-generation stars, made almost entirely of hydrogen and helium. For decades, these stars were only theorized. They'd be massive, unstable, and short-lived, burning out in just a few million years. If JWST had truly seen them, it would be a glimpse at the very first light in the universe. But what's even more puzzling? Some early stars JWST observed seemed to be too massive and too numerous for how young the universe was at that time. A few may even exist within globular clusters, which again shouldn't have had time to form. Could this mean our timeline of the early universe is off, or is something stranger going on? Chapter 3. The Big Bang Under Fire. JWST wasn't designed to disprove the Big Bang, but its data has opened the door to uncomfortable possibilities. Some scientists, like astrophysicist Rajendra Gupta, have even proposed alternatives, that the universe may be older than we think, by double. Others suggest that our models of cosmic expansion, star formation and galaxy evolution are too simplistic, that dark matter and early feedback processes behaved in ways we haven't accounted for, but more fringe voices have begun to wonder, what if the Big Bang isn't the beginning? What if it's just the latest chapter in an eternal cycle? Of course, the overwhelming majority of scientists still support the Big Bang as the best available model. But when one telescope begins punching holes in the timeline, even quietly, the conversation starts to shift. What else are we getting wrong? Chapter 4. The Dark Matter Disturbance. Another mystery, JWST's challenge to dark matter theory. Dark matter is the invisible scaffolding that supposedly holds galaxies together. According to simulations, early galaxies shouldn't have been able to form without vast halos of dark matter. But many of JWST's early galaxies appear far more compact and massive than expected. That's a problem. Some galaxies look too dense to be consistent with how dark matter is supposed to behave. Others showed surprising rotational symmetry, suggesting an internal structure more stable than should be possible without mature dark matter halos. If this holds up, it could mean we need to revise our entire model of how dark matter interacts with visible matter. Or perhaps, dark matter isn't the right answer at all. Chapter 5. Gravitational Lensing Gone Weird. JWST is also a master of gravitational lensing, using massive foreground objects like galaxy clusters to bend and magnify light from objects far behind them. It's like a cosmic magnifying glass. But some of the lensed images don't quite add up. In a few rare cases, JWST has revealed lensing anomalies. Multiple images of the same galaxy appearing in configurations that deviate from predictions. In one case, light paths seem to contradict known gravitational lensing laws, as if there were invisible mass structures distorting spacetime in unexpected ways. Are we seeing rogue dark matter clumps, or is this something even stranger? And what does it say about the geometry of our universe? Chapter 6. Infrared Ghosts and Phantom Galaxies. Some of the faintest galaxies JWST detects in deep field observations seem to appear, then vanish, as data accumulates. Astronomers call them infrared ghosts. Extremely red, distant signals that seem real, until they don't. Some may be noise, others, processing errors. But a handful resist easy explanation. One candidate, dubbed GLZ-13, appeared to be the most distant galaxy ever found, until follow-up analysis cast doubt on its redshift. Could these be echoes of ancient cosmic events, light warped by gravitational anomalies, or something even weirder? We still don't know. And perhaps, that's the point. Chapter 7. Webb's Glimpse into Alien Atmospheres. Not all of JWST's mysteries are cosmic. Some are exoplanetary. The telescope has already begun analyzing the atmospheres of planets dozens of light-years away, scanning for biosignatures like water vapor, methane, carbon dioxide, and even oxygen. In one strange case, WASP-39b, it detected carbon dioxide in the atmosphere of a hot gas giant. That's not unexpected, but the precision was astounding, and the implications huge. JWST can now build full atmospheric profiles of planets we can't even see directly, which raises the ultimate question: what happens when it finds something it can't explain, on a planet like ours? What if it sees industrial pollutants, or chemicals that shouldn't be there? How will we know if we've found life? Or worse, evidence of something artificial? Chapter 8. Something broke the timeline across its first 2 years. JWST has hinted at something fundamental. The timeline of the universe may be broken. From oversized galaxies to anomalous redshifts to unexplained brightness, Webb's data is poking holes in the standard model. It's not just about speed of formation or size, it's about sequence. Things are showing up out of order, as if we missed a step, as if we assumed too much. This doesn't mean the Big Bang is wrong, but it might mean it's incomplete. And if the timeline is warped, what else is out there, hiding in the folds? Chapter 9. What comes next? The James Webb Space Telescope is just getting started. Its lifespan is expected to extend into the 2030s, and with each year, its observations will go deeper, sharper, stranger. Already it's forcing us to confront uncomfortable possibilities, that the early universe was more chaotic, faster evolving, and more diverse than anyone imagined. That our models, our neat diagrams of cosmic evolution, may be illusions of understanding, but that's what science is supposed to do, not to confirm our beliefs, but to challenge them. And few instruments in human history have ever challenged so much, so quickly. The eye that looked back too far. The James Webb Telescope is not just a machine, it's a time traveler, a mirror, a question. It doesn't just see light, it sees what light has become after traveling 13 billion years. It sees the universe before there were stars, before there were galaxies, before there was us, and what it sees is not always what we expect. So what did JWST really discover? Perhaps the most frightening answer is that we don't know. Not yet. But it's still watching, still searching, and somewhere out there in the dark, something is waiting to be found.